All right, so today we're covering measures of center. When we get back in touch on Tuesday, we're going to be doing measures of variation. Again, this is something that we've done several times. The key thing is just relearning the vocabulary, relearning how to use the technology to get to what we need to do. Our goals today is to determine the arithmetic mean of a variable from raw data, determine the median, and then also what does it mean to be statistically resistant, and then determine the mode of a variable from raw data. So some basic definitions as we go through: the arithmetic mean of a variable computed by adding all the values of the variable in the data set and dividing by the number of observations. So that's typically what we've taught you all the way through, from late elementary school up. We said, hey, let's find the mean of this data. So you just add it up and divide it. Now we're going to be a little bit more specific about things. We're going to be asking about, hey, there's a population mean and there's a sample mean. And when we look at the population mean, it is represented by the Greek letter mu is what it's represented by. Typically, all symbols that are representing the population are Greek letters. Okay, is what they typically are. If it's a normal letter in the alphabet, it's typically going to be a statistic for the sample, is what it's going to be. There's one exception when we get to talk about when we talk about the population proportion. It is a capital P, whereas the sample proportion is actually P with a hat on it, and so it actually looks a little bit different. So so we'll talk about that when we get into the course. But most you can get away with saying, when I see a Greek letter, that answer, that number is representative of a parameter of the population. Now, the formulas computing both the mean of the population and the sample are identical. The only thing different is what the n value is. Capital N is the whole population. Lowercase n is your sample size. And we're going to walk through an activity here where we have to find the mean for the whole entire population because we don't have a lot of data, so we can do it. And then we start doing some random samples of the data, and then we calculate those means. And we'll see that the two answers, the sample mean and the population mean, may not be exactly the same, and that's okay. And then that's where we're as we do things, we're kind of showing a little bit of a relationship. There's a difference between them. So computing a population mean and a sample mean, we have some data here in on the left-hand side here that we're going to use, and we're going to go straight to the calculator to do it instead of doing it by hand. We want to find compute the population mean, so I need to find out what mu is. All right, that's the first thing I need to do. And then I need to figure out what x bar is. That's the sample mean, okay? So population, sample. Now, and they tell us that our sample size is size 4. And they asked us to do a simple random sample. So as you take your notes and we get ready to do the sample, you can either use mine as your template, or if you want to do your own, that's fine. You just realize that we may have different sample means. So as I split this over, I'm going to go back into I'm going to go online to the TI-84 calculator. And I'm going to go in as we go to, I'm going to go into, have we entered data in? We did for histograms, right? And have we entered data into a list yet? No, okay, good. So I don't want to go too fast yet. All right, I need to make sure I slow down. So I press stat. So once you turn the calculator on, press stat. And when we're entering data into a table in the calculator, we're going to go ahead and press enter on edit in this very first feature. So we're going to go ahead and press enter. And then I'm going to type in my numbers. It doesn't matter the order. Just type them in there. And as I do this, I'm going to ask a question when we get done here in a second just to see. And we're going to get a lot of practice using this today. All right. Is anybody using the Calc 84 app on the iPads? Okay. The only reason I ask is when you're using that feature, that app, you have to press enter on the last number. If you don't press enter on the last number in there, it won't put it into the calculation as you have it to do stuff. I found that out the hard way a couple years ago when kids and I were getting different answers, and I was using the online, on the screen thing, and they were using the calculator, and I finally figured out that I didn't press enter on that last data value thinking that it was okay. It was there. Hey, it's in there. But on that app, you have to press enter. So now, has everybody got it in there? So that's step one. Go into stat, press enter into edit, type in your data. It is typically safer to get out of that by doing second mode, to quit the screen. All right, because some of the programs, if we don't do this, it'll actually put what we're doing next into something else, and it just really jumbles everything up. So whenever you get done doing something and you're switching features, get in the habit of doing second quit. That way it kind of breaks that. We're now going to tell it to do, what we're going to try to do is we're going to do what's called a one-var stat. We introduced this to you guys in Algebra 2 for some of the classes. So we go to stat again, go over to calculate, and there's all of our different calculations we can do. We have a one-var stat, we have linear regression, quadratic regression, which we get into when we start doing your lines of best fit. The word tests, just to show you, the word test there, that's pretty much our whole life after spring break. Doing our confidence intervals and our hypothesis testing. That's where they're going to be there. So I'm going to go back here, press enter on one-var stat. This is where I tell the calculator, hey, where did I put my list? I put it in L1. So I'm going to arrow down. We leave the frequently see list blank. We don't put anything in there. Go down to calculate, hit enter. And the very top thing, I know it says X bar, but I used all this data, so the mean is 79. At the very top where it has that, is the mean is 79. We used all of the data. So the population mean is 79. Now they're asking us to do in part, and the next part is find a simple random sample of size 4. All right, so they gave us already a numbering process here. They numbered everything from 1 to 10. So I'm going to go in and use the calculator to help me do that. So I'm going to go in and do math, go over to PROB. I'm going to go down to option number 8. Random integer, no repeat is what I'm going to do. And I'm going to press enter. My smallest number in the coding was 1. My biggest number in the coding was 10. And I'm going to have it pick 4 of them right for me off the bat. I'm not going to repeat the process one at a time. I'm just going to tell it to pick me 4 numbers. All right? And I'm telling it to not repeat any of them. And then I go down in here and I hit paste. And then do one more time on an enter. And there is my sample of 4 numbers that I'm going to now add and find the mean of. And that's going to be my sample mean. Okay, so this is my sample. You may have gotten anybody get different numbers than I did? Okay, then that's fine. That's what happens when we're looking at random. We may not all get the same stuff, and that's okay. We're just doing a simple random sample. So now I'm going to go through and find out what is the mean of mine. So what is 88? You do that. If you have something different, find the mean of yours. If you're using my data, go ahead and find the mean. 77, number 6 is 68, and 62. And I got to divide that by 4. All right, so 88 plus 77 plus 68 plus 62. Enter, divide by 4. Enter. And hopefully I didn't have any happy fingers there. So my mean for my sample of size 4, my mean was 73.75. Now, were those the same answers? No, and that's okay. A sample mean is not always going to equal the population mean. It sometimes may. It sometimes may be close to it. Anybody get a sample mean that was higher than the population mean, out of curiosity? Anybody get a sample mean that was bigger than 79? Is it possible to get a sample mean as we look at the data? Is it possible to get a sample mean of 4 values that's bigger? To me, if you happen to use like Juan, Justine, Sam, if you were lucky, and then was that Bilal? Those ones there, those four added together are going to give you a sample mean bigger than, what the population mean is. So it's possible to get a sample mean bigger. I don't know if anybody got a 3, 8, 9, and 10. We could repeat the process multiple times. So again, as I looked at homework, they do ask you, they'll say to the left of a set of 5 digits, they'll say population, and they give some numbers, and they have 2 blanks, mu and X bar. Pay attention to what word is next to the numbers. If it's population, then they want that answer for the mean to go in the next to mu. Okay, if they say sample, then you want to make sure that goes in for X bar, and when you go to type it in on the homework. Okay. All right, let's go back over here. All right, the following data represents the pulse rates in beats per minute of 9 students enrolled in a section of Mr. Sullivan's introductory statistics course. Treat the 9 students as the population. They asked us to figure out, okay, what is the population mean pulse? Find 3 simple randoms of size 3. So you're doing it 3 times. Sample random samples. SRS 1, SRS 2, SRS 3. And then they asked us some questions there, a little bit here. So where's my data? Did Mr. Stevens forget to put the data in there? Well, shoot. All right, so let me get you some I know what I can do on fly. I got 9 students in my stats class. So let me cut and paste, put some in there. Go ahead. Cut and paste that. Back over here. I'm going to put this up on my screen, that way we don't have to worry about it being like distributed out, taking forever. So I'll change my screen here in a second so you can see it. All right. So I just put this table of 9 students. I have 9 students in my last class. So we actually did a activity of pulse rates. So here's student 1, 2, 3, 4, 5, 6, 7, 8, and 9. So there are my 9 students. And what I want you to go through and do is go ahead and put them into L1. Find the population mean. So find mu for these 9 students. And then you need to do a simple random sample 3 times of it picking, 3 students. And then find what the X bar for each one is. The SRS of 1. What's X bar for that? That's horrible. Again, I'm going to do that on my screen here for the video for those that are out here. So, there we go. Get back into data. Enter on my list. Now, you don't have to delete each one of those one at a time. You could actually go up to the top of the column header and hit the word clear and then arrow down and it wipes out the whole column. Okay? Again, if you go up to the top of the column header and then hit clear, it'll wipe out the whole column when you go down. That's a faster way to get rid of it. Don't press the word delete. When you do that, if you press delete, it deletes the whole column, including the title. The whole column disappears. And if you're using one of my calculators and it's missing, let me know. I can get you it back. 99, 77, 81, 86, 100. Bless you. 85. All right, so I got mine in there. And then now we're going to go second mode to quit the screen. Go into stat. Bless you. Go over to calculate. We're going to do one variable statistics. I got all my stuff in L1. Fantastic. Go down to calculate. My population mean, mu, because I used all of the data, my mu was 89.5556. Remember, pay attention to decimals. We will be doing things out to the fourth decimal place, rounding it to the fourth. So take it out 5, round it to the 4. As I looked at most of your answer stuff on the test yesterday, a lot of times they were asking you to go to the fourth decimal place on some of those answers. Some of them they asked, to 2. When they had it in percent mode, they said round to two decimals. But we'll be doing a lot of stuff out to the fourth decimal. So now I'm going to get my first random sample. So quit the screen, math, go over to PROB, random integer. I'm going from 1 to 9, and I'm doing 3. I want 3 at a time. So my first one is student number 7, 1, and 4. I'm going to go ahead and do it again to get all the next 2 sets as well. Second enter puts that last thing on the screen, and I get 9, 2, and 8. So 9, 2, and 8. And then I'm going to do second enter again, get the last sample, enter, and I get 9, 2, and 4. All right, so those randomly got used twice. Okay. All right, so now let me find my mean of those. So student number 7 was 93 plus 105. Number 4 was 77. I got to divide that by 3. So 93 plus 77 plus 105 divided by 3. All right, so that first one, X bar 1, had a thing of 91.66667. My second sample was 928. So 85 plus 79, and then 82. So 85 plus 79 plus 82. Sorry, didn't put that 2 there. 82 divided by 3 would be 82. X bar 2, 82. And then my last one, again, it's 85 plus 79, and I got to use number 4. We used that one already again. That was number 77, so plus 77. And so 85 plus 79 plus 77, enter, divided by 3. Boom. That gives me 80.3333. All right, so we know what our population mean is. I get rid of my calculator. Population mean, I said, was mu was equal to 89.5556. My first simple random sample was 91.6667. My second one was 82 flat, and then 80.3333. And then now I get to answer some questions. Which sample results in a sample mean that overestimates the population? Well, for me, my SRS 1, using student number 9, it wasn't 9, it was 7, 1, and 4. 7, 1, and 4. So using students 7, 1, and 4 allowed me to have an overestimation. Because that sample, when looking at it, 91 is bigger than 89. Which samples results in sample means that underestimates the population? Well, both of my samples 2 and 3. So my SRS 2 and 3 underestimate. And then the third question here says, do any samples lead to a sample mean that results in a population mean? Did anybody get really close with the way you got your 3 random samples if you did them different than me? Get it really close to that 89. Anybody have a set of numbers got super close to the 89 out of curiosity? Okay. All right. Is it possible? I'm just looking at the numbers to see if it's possible. 89. I don't know. It may be tough. It would be a lot of playing around with it because we just, with 9 datas and we jump from 77 up and we're not, you know. Yeah, but
What's the difference between us like doing all of the stuff in the calculator and just adding them all together? Is there like or does that just set us up for the last part as well?
oh, you mean, you know, why are we doing this stuff in the edit column? Because we have some more stuff we're going to that is good that was listed below the X bar that we're going to be using. So instead of you just doing it the old way, the way we taught you when you were in elementary and middle school, add up, divide. Some of those other symbols that were on that screen from the 1var stat, we're going to be using tomorrow and the next day for answers. So I'm just trying to let you go one place to get all of your information to make it a little bit easier on you and stuff. There's nothing wrong with doing it that way. Okay, it just
I didn't know if like you get a different answer.
no. You doing it by hand, adding up all 9 divided by 9 would be the same. You adding like I did those 3 different ones by 3, yeah, that's fine. It's just we're going to be getting into so much stuff that 1var stat feature is going to make our lives a lot easier and stuff with all the other things we got to do through this chapter and some of the other chapters. Okay, so I chose to kind of introduce it to you guys quicker than maybe the book would have done, just to try to help you do things. So again, I was just playing around in my head trying to think about if I want to get close to 89, maybe if I do like 100, the 86, and the 85, maybe if I add those 3 numbers up and divide by 3, would I get pretty close to it? I don't know. That'd be 180, let's see, that'd be 171, 271 divided by 3 gives me 90.3 repeating. So that's pretty close. All right, so is it possible? Sure. Now, that wasn't a random. I just looked at numbers saying, hey, what got me really close to 89 below it, 2 samples of it, and then one of the other big numbers to try to get me to that part there. So again, there was nothing random about that. But it is possible. You know, so on to answer that third question here, I would say yes, it's possible. Yes, it's possible if students, I used, what did I say I used? I used student 9876. I used student 6, 5, and 9. I used those 3 students and got roughly 90.33, which is pretty darn close to 89 point something. Okay, so it is possible. You know, we might just have to keep doing that random number generator till eventually we get that magical combination for it to work there. But again, they're not asking us to do that. Median. The median of a variable, we know it's in the middle. We got a list of stuff from smallest to biggest. Here is a concrete way if you forget how to find the median. If there's an odd number of terms in your sample, it's the number that's exactly in the middle. If you have let's say you had 31 numbers, well, they're telling you, hey, all you have to do is really do 31 plus 1 divided by 2, and that tells you what number you need to search for in the middle as you start counting. Okay? That's, again, if you're doing it by hand. If you have an even number, there's another process. Now, here's the reason why I had you guys do the mean the way I had you do it. Scroll back over to the screen or on your calculator. Get back on your calculator. I'm going to scroll the screen back. And I'm going to get back into that 1var stat. I'm going to do one var stat again on what I have in L1. And there's a bunch of symbols on there. The SX, which is like underneath those two sigma symbols. We get to talk about this SX tomorrow. That's the sample deviation. The next symbol down below it is the population deviation. Again, that's tomorrow's, not tomorrow. That's Tuesday's lesson. The next time we get together, okay? So we'll be using this stuff to get us the deviation answers on our next lesson. If I scroll this screen down and I look a little bit further, we'll notice what pops up. Smack dab in the middle, it says MED, median. All right? Now again, when you're given 5 numbers, it's pretty easy to put them in order from smallest to biggest and find the third term and hey, that's my median. But we're not always going to be dealing with 5 numbers. We may be dealing with 25. We may be dealing with 45. All right? And I really don't want to arrange by hand numbers from smallest to biggest because it just takes too long. That's where using the calculator feature, we get so much information out of this for everything that we need to do in the measures of center, which is today the mean, median, mode stuff, and then tomorrow, the next lesson, the variations, and as we keep going on from it, okay? So that's the purpose behind why we're using that one feature. So I took this off of the answer there that you don't see it. But go ahead and do me a favor. Type those numbers in. And I'm going to do it on my calculator. Type those numbers into L1 and then identify what the median is. And see, is it what they have here? They're saying it's 217. I want you to find it on the calculator to make sure that you have it that way.
Coach Stephen,
Yes, ma'am.
can you have Audrey Vaughn see me after this block?
I sure can. Yes.
Thanks.
Yep. Yes. Do what?
So I can get to like the point where we put in like the list and everything.
Sure.
And then we get to once we get to, sorry, when we get to,
Okay. Okay. When we do that random manager, I'll walk you through that one again. Okay. Sure can. All right. So we're going to put our data in here again. Column header, hit clear. 201, 257, 284, 208, 179, 222, 217, 206, 240. All right, and let me double check. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, I got 9 items. Okay, then I'm going to do stat. Calculate. One var stats. Calculate it. And then I'm going to scroll down, and they tell me on this thing, 217. I see that on my screen. I see that right there, even with that arrow. So my median is 217. We did notice earlier in the book, they do use the capital M to stand for median, is what they use as we do things. So, again, the next test you guys take from here on out for me until we take the final, well, actually, the final is paper. All the tests from here on out are all paper version, okay? That was the only one I was doing online just because of the graphs and the definitions. It was just easier to let it randomize, do it that way. The rest of them, I make them up by hand. So we got to make sure we're labeling things as we do stuff. Any questions on finding the median? Again, when you don't have to do it by hand and you're using technology, it goes really quick. And that's where I would suggest as you do the homework and practice for preparing for our tests in a couple weeks, hey, get used to using that feature. You're allowed to use the calculator with it. Let's get familiar with doing the stuff that way. Now, second bullet point, what it means for a statistic to be resistant. A numerical summary of data is said to be resistant if extreme observations, your outliers, basically, when they're talking about very small and very big. We get to say a numerical summary is resistant if extreme values do not affect the value substantially. It may, and we're going to talk about it in a moment here, and we'll look at some examples. The median is resistant. It is what we classify as being resistant. An outlier doesn't affect the median because it's a place. It's a place in order. Whereas the mean is not resistant. The mean is affected by outliers. They are affected by the outliers. And we talked about that in our skewed graphs in the previous chapter. And we said, okay, if it was skewed right, what was greater, the mean or the median? So if I had a graph that was skewed right, so it was sloping down to the right, I asked the question, is the mean greater than the median or vice versa? And we said that the mean was greater because the outliers that are on the skew part to the right make the mean be a lot higher than what it should be. Okay? So the mean is not resistant to an outlier or extreme values. It's going to be, so those, depending on how far out it is, could dictate how much it changes by. Okay? The median, again, it's a locational thing, so it is resistant to an outlier. When to use the mean or the median? So, if we are skewed left, the mean is substantially smaller than the median. If it's symmetric, they're about the same. They're right about the same if it's symmetric. And then if it's skewed right, the mean is a lot larger than the median. And then we have a couple graphical representations of it. And if you want to add this note here, when the data is skewed, doesn't matter the direction, use median to describe the center. And then when the data is symmetric, use the mean to describe the center. And we have some activities we're going to go through here to try to show you how an extreme value, when we remove it, how it does change what's taking place there, or if we add an extreme value, how does it change the mean and changes stuff. All right, the data in Table 5 represents the birth weights up in pounds of 50 random sample babies. Find the mean and the median birth weights. Describe the shape of the distribution. Which measures of central tendency better describe the typical birth weight? So with that in mind, we're going to enter that stuff in real fast. And you're like, Mr. Stevens, that's 750 numbers. That's not real fast. But again, we don't have a lot of examples here. I did leave on your notes, I think, the picture of the histogram, so you don't have to draw it. But just to give you a chance to practice getting that stuff one more time, we're going to go in there and put that stuff in there. Boom. Oh, there we go. And stat, enter, up, clear. Oh, shoot. All right, there we go. All right. Oh, shoot. There. Daggone it. I'm up 50s. All right, where did I see that negative 51 there? 7.6. Where is it? 7.6. How did I get negative 51? All right, 7.6. All right, so it's the 7.1 and the 7.2. So that needs to be 7.1, and then I need to get down here and add another 7.2. I hope I did. I hope that worked out right. All right, stat, calculate, one var stat. Boom. All right, so hopefully if I did this right, did anybody else get the mean of the population to be 7.4888? Good. All right, so I did fix my one mistake. Okay, good. I made it correct. And then now we got the median is equal to 7.35. All right. Technically, mu is like, there you go, something like that, a big old little tail. And then you have looks like a U. So there's my two things. Very similar. They're close. I mean, those are very darn close in numerical value. And so it shouldn't surprise me that when I look at my graph, it is sort of symmetrical. Okay, it is sort of symmetrical. Not perfect. There's not enough skewness on the right-hand side. There's really not any major outliers. We get to learn later in this chapter how to test for something to be mathematically an outlier, not just by visual looks. There's a process. It's called the IQ, the 1.5 IQR rule. So we'll actually have to do that calculation. So to me, it makes sense that, hey, the mean and median, they're close together. They're somewhere in this stack right here. And again, if I was asked to describe the center, I would be actually using the mean, since this is approximately symmetrical as I go about to describe it. Oh, come on, you little turkey bird. There we go. All right, scrolling through. All right, how would we describe that? What kind of shape would you say? Is it approximately symmetric? Does it look skewed? If it's skewed, which way is it skewed? I would say it's approximately symmetric. It's not bad. Which measures eccentric tendencies better describe the center of the distribution? The mean. It's not wrong to say what the median is, but again, the median has to be used when it's skewed. So whenever it's approximately symmetrical, or we're going to tag onto it approximately normal in our lessons tomorrow, then we use the mean. Okay. If it's skewed, it's got to be the median. The mean, we're gonna go towards being, it's okay to be the when it's symmetric. All right. How about this one? What kind of shape do we see here? Is it symmetric? Nah. This one is skewed right. Again, skewed right means there's a lot of data on the left side, very little data far out to the right side. We're looking at maybe a potential outlier here, because it's so far away from the right there. So we're going to say this one is skewed right. So we're going to use the median to describe it. We're going to use the median. Any of y'all parents in real estate or real estate agents, out of curiosity? Usually when you look at, listing a house or buying a house, and a lot of times we have a price value, but they also display things more on the median amount. What's the median house value for 3-bedroom, 2-bath? They don't do the mean, because sometimes there's those outliers that cause the mean to be a lot bigger than what it should be. Okay, so in real estate, they use the median to be a more accurate picture of, what the rough price of a 3-bedroom, 2-bath house is as compared to the mean. Mode, we learned this a long time ago. Mode is the variable that is most frequently observation. It is the highest peak. We learned in the previous chapters we can have more than one mode. We can be bimodal, we can be trimodal. And so in this little example here, they just ask you we should be able to see, hey, what number is the mode? Obviously, it's the 0 because there's so many zeros there. How many times was it listed? I think it was listed 17 times is what it was listed. And I saw a clip on Facebook. What's today? 29th, 30th? Yeah, 2 days ago I saw a clip of the space shuttle on that date. I was in the 9th grade when the space shuttle exploded. We were sitting in science class, watching the TV because the teacher was going up for the first time in space, and within a couple minutes of liftoff and stuff, it exploded in air and stuff. So it was like that was the first of several different shuttle explosions. So. Came down to a little O-ring, a little washer failed, and a couple of them failed, and that's what caused it to happen. So, and we may see that revisited in the probability. What's the probability of that success, that type of failure occurring? We'll see pop up usually in about chapter 6, trying to calculate, well, what is the probability of a successful launch when there is a certain failure rate with these little O-rings malfunctioning? And I've seen them in several statistics classes pop up as examples and so forth. So here's a little brief, snapshot of what we did today, if you need to use it to study off of. And then I just have some more practice problems for us to kind of go through together of you going through, doing the mean, the median. I want to scroll through it real quickly there, match the histograms there. So we're just matching up, scrolling through, determine the mean and medians. Okay, yeah, let's skip down to this one. Let's skip down to this this exam scores one, because this is where we get to talk about how numbers affect stuff. So as we look at this example here, it says the data, the next column represents the exam scores in statistics class taught using traditional lecture and doing a flipped class. The flipped classroom is one where you put the stuff out there via video, and then in class you do homework and other activities. I toyed around with that at one stage right when COVID happened, before it happened, and I was working out great. The kids would go home, watch my video, and take notes at home for homework, 25-minute lecture. And then the next day, we just practiced in class. They did the homework in class. I led activities in class. And it was going great, and then COVID hit. And then it was just kind of hard to kind of do things and stuff. And I've always thought about going back to it. But I know sometimes it's hard for some students because of outside activities, whether it's work, it's sports and extracurricular activities. Sometimes to sit and do detailed notes in a 30-minute block and stuff at home and stuff, and it's tough. But I've always thought about going back to doing it with some of my classes. They want us to go through and determine the mean and median and comment on the difference. And then they said, okay, what happens? What happens if we didn't type in the 59.8 score and we actually typed it in as 598? How would that affect the mean? How would it affect the median? So let's do that. Let's put in the traditional in an L1. Let's put that into L1. And let's see what the mean is correctly done. So stat, go up there. Whoops, boom, 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 boom. Clear. All right. So 70.8. 61.1. Again, I'm going to ask you in a minute here when I get done with getting my one VAR stat to make sure I didn't have happy fingers. And I hit a miss key it, see if anybody else got the same. As we look at the mean here, I used the whole population, so mu would be 71.8154. Again, I don't know if anybody missed stuff because they rounded wrong. Again, rounding to the fourth decimal means take it out to the fifth, then round accordingly. And the median, if I scroll down, was 70.8. Did anybody else get that same mean? Thank you, dear. Okay. Now I'm going to go back in there and get into my thing, and I'm going to take the score they said that was the 59.8. And then change it to be 598. Thinking about it, that's a lot bigger of a number compared to all the other ones, so I should be thinking about the mean should be a lot bigger. We went from all 2-digit numbers to now we throw in a big 3-digit number. So it should increase the mean is what should happen, is what I should think. All right, now I hit stat, calculate, enter our stats, go down to the bottom. And look at what that means. So with 598, the mean was equal to 113.25. 2154. So it did. It changed it big time. Just one little thing can affect it. An outlier can affect it greatly. And that's why we got to be careful when we're typing data in, because it's easy to make a key mistake. Like as I caught myself on one of those other examples, I noticed I had a negative 51.12. That was going to change what the mean should have been. You know, instead of adding stuff, that now subtracted away from the grand total of stuff. And that's why I asked you guys, did anybody else get the same thing I did, just to make sure I didn't make a goofy mistake with the fingers. Okay. How does this affect the mean? We would come up here and say that it makes the mean a lot larger. What property does this illustrate? Now, did the median change? I don't think I wrote the median down. Median was 71 point. The median was 71.5. Well, that didn't change much. That's not a substantial difference, and that's where they're talking about that the median is resistant to outliers. It may change a little bit, but nothing substantially. Going from 70.8 to 71.5 is not a big substantial difference. Okay? The only reason why it changed was because the 59.8 was technically on the left side of the first median. Now making it a 598, put it on the right side. So it changed the two numbers in the middle that we had to add and divide by 2 by, since we have an even number thing. So that's why it did change. It changed we had two different numbers. Probably had like a 71 and a 72, because that the difference between those would be 71.5. All right. Again, here we did transform it. Since we were adding a amount, it transformed it by adding an amount to the mean, is what it ended up doing. They're not looking for you to specifically say what those are. We'll hold off on the M&Ms just because there are a lot of things to do there. Let's finish up class. Let's see, that's how many numbers? Let's see, that one's got 5. Let's do number. I have problems for homework on your set. just like these last two problems here. So that's why I wanted to make sure we got to them in class. Let's do the last one first, just because it's got smaller data to work with. It's only got 5 numbers, so it's a little bit quicker to do in the calculator. If we get more time to do the one above it, we will. It says use the 5 test scores and then they want us to find the sample mean, then the median, and then which one is better to describe the typical test score. So let's go ahead and put that in our calculator. Boom, 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 boom. And I got my 5 numbers in there. Going to do my 1 var stat. Now the challenge with 5 numbers when we go to do a histogram, it's going to be tough to tell if it were a dot plot. It's going to be tough to tell if it's skewed or not. But I do know that my mean is 75.2. My median is 71. They're close. Again, it's going to be tough to do a dot plot on this one, but I would say that 95, we'd probably say that's an outlier because it's so far away from the rest of these. So if we did a dot plot or a histogram, we'd have a lot of data over on this side, and then it would be skewed out to the 95 over here. So from 65 to 75 is where most of the data is. And so this would be skewed right. And again, the mean is bigger. It's not much bigger. It's 4 bigger than it, 4.5 bigger than it. But that also lets me believe that it is skewed right. So which one would be a better to do? That would be the median. We should use the median in this case, because that 95 is an extreme value. It's not close to the other ones. So we should use the median to describe stuff. Am I going too fast? Am I okay? All right, next part. Suppose the professor decides to curve the exam by adding 4 points to each test score. Compute the sample mean based on the adjusted score. All right, let me show you a trick in the calculator. Get back into that table. Don't add the 4 by hand. I'm going to show you a little technique that will help speed things up when you're trying to do something like this, adding 4 to everything. If you go to column 2 and go up to the column header and you highlight the column header L2, this is where we can tell it to do a calculation, and it'll fill in values in that column. So I'm going to press second and the number 1 to say, hey, I want you to take the numbers in column 1 and I want you to add 4 plus 4 to every number. So again, I went to the column header L2, pressed second 1, said I want column 1, I want you to add 4 to every single number. And when I hit enter, it automatically adds 4 to every single one of those numbers. Okay? Now again, we only have 5 numbers. That wasn't that hard to do by hand. But what if we had 50, like one of the other examples we did? All right? I'd rather do this and let it do all that math for me real quick. Now they ask me to go through and find what is the new mean. So what is the new mean based off of after adding 4? So now we'll go in and do a 1 var stat, but we got to change the column we're doing it on. We want to find it on column 2. So that means I do second 2, and that changes it to an L sub 2. Second 2, and then I go down to calculate, and I find out that the new mean is equal to 79.2. So what did it do? I just added 4 points to the mean, right? The old mean was 75.2. The old mean was 75.2, and when we added 4 points to everybody's score, the new mean was 79.2. Well, that's just taking the old mean and adding 4 to it. Okay? And that's one of the things as we look at our transformations is when we add or subtract a constant amount to every data value in the sample, the mean is changed by that same adding or subtracting amount. Now, let's take a look at the new median. I'm going to leave that up there so you can see all my stuff. I didn't grab the new median yet, but let's go through and let's find the new median it should be on my display here in a minute once I go back to a split screen. Let's see if the median changed by the exact same amount. And if I swipe left, get my calculator up there, scroll down, median is 75. Did we add 4 to that one too? The new median was 75. The old median was 71. So, yeah, it added 4 to the median as well. The old median, we just added 4 to it. So we could actually adjust when we add or subtract a constant amount to every data value it should be sample. How did I put same? Sample. The median and mean, both of them, median and mean now, are changed. We can actually tweak that to say mean and median are changed by the exact same amount that you add or subtract. Again, that speeds stuff up. When I add or subtract a constant amount to every data value, not one value, every data value in the sample, the mean and the median are adjusted by that exact same amount. So whatever the old stuff was, mean and median, the new ones are added the same amount or subtracted that same amount that you did. Again, we just did what part E was. We compared the two. And then we just made basically a statement of saying that, hey, if I add 4 to every data value, the mean is automatically added by 4, and the median is also added by 4 from what the original was. The longer, more detailed one is this middle problem. And here, and this is a good one too, because they have us doing an addition. And then they go through and add the bonuses, and then they say, okay, let's do a percentage amount. Okay? Let's do that one, and that'll be the last one we'll do today, because again, we have one like this in homework, so I just want to make sure we have one on the video and in notes. So let's get in there. Let's put our... Now here's where we got to be careful. All those salaries are in thousands. So with that in mind, are you typing in 30 with 3 more zeros? With like 30 and then 3 more zeros, or are you typing in just 30? Because that dictates how we put in the $2,500. So how many of you all want to just do it as like 30, 30, and so forth? Okay. So if we do it that way. So let's say we do that. Enter. Let's clear those out. Clear the columns. Now we do need to do the first column with just the 30s and just so we have that there. So 30 plus 30. Oh, no pluses. 30, enter. And I missed one person. There's an extra 50 in there in the middle. All right, so I have all of my people there. And then we can get for part, we can do the mean one. So let's find a one var stat on that one real quick. Go back to column 1, second one. All right, so the mean is 50K. The median should be 50K, great. All right, now, as I do my first change, is I take it and I add the 2,500. Stat, enter. Now, as we go up here, we're going to take column 1, so second one, and I'm not adding, it's actually technically adding 2.5 is what I'm adding. Since I'm not putting in the extra zeros, 2,500 is actually 2.5 thousand is what you would say it as. So I need to add 2.5 to all those. That way it's, the ones column is the main part that changes. So now that I hit enter, and then I go through and do a one var stat on that column, change it back to L2. And I noticed that the new mean was 52.5. All right, it added 2.5 to 2,500, and the new median was, scroll down, 52.5 again. All right. So that's one option. So the mean amount increased by $2,500. The median increased by $2,500. As a second option, Benjamin can give each employee a bonus of 5% of his or her original salary. Add the bonus under this second plan to the original salaries to create a new data set. Recalculate the mean, median, and mode of how do we compare to the originals. All right, so let me think about this one as we get ready to put this one into column 3. Long-handed on a piece of paper, we would take each person's salary, multiply it by 0.05, get an amount, add it back to the original, and that would be what their new salary is. Now, how can I do that faster? I take each person's salary and multiply it by 1.05 is the way I do it faster. So on the column header, I'm going to say I want to do 1.05 times and then column L1. And I'm going to hit enter. Now, I can double check myself doing one of them by hand just to make sure before I do stuff. Again, if I do, I'm trying to think where I got an extra calculator so I don't mess up the screen. If I take 30,000, oh, hello, somebody wrote me hello on a calculator. Oh, so sweet. 30,000, so 3123 times 0.05 gives me 1,500. Added to the original 30,000 gives me 31.5. Yeah. So okay. So there we go. We got the right formula up there. So now as I do a one var stat on that column, and I'm going to change that to be column 3. Make sure I didn't have happy fingers on that one. Did I change it to column? Yeah, I did change it to column 3. Okay. All right. Double checked. Now, why did I double check?
It's the same as the last one.
Yeah, it was the same with the last one. So I just wanted to make sure I did change the column because it was the same exact answer. So I just wanted to double check that I did change it to L3. All right. So with that, for part C, the mean when we multiplied by 0.05, a 5% raise, that was equal to 52.5, and the median, again, was 52.5. again, as we compare those things, we would say, hey, there's no difference between giving everybody a 20, for the total amount, the mean's still going to be the same whether I give everybody a $2,500 raise or a 5% raise. Okay? The mean is going to be the same. The median is going to be the same. Now, it's different for each individual, all right? Because, some of them got if we go back and look at our table, so, that first person got a $1,500. But as I look at the one with $45,000, they actually got to $47,250. So they got a $2,225 raise or $250 raise compared to the first two people got $1,500 raises. Okay, so not everybody got the same amount of a raise. They just got the same percentage of a raise. The last option here, D, says as a third option, Benjamin decides not to give his employees a bonus at all. Ooh, bad mistake. He keeps the $2,500 for him, or $25,000 for himself. Use this plan to create a new data set. Well, I'm assuming when we look at the data set, that's Benjamin right there. Benjamin's $75,000. So I'm assuming Benjamin earns the most in the company. So if we go through and we go back to our little calculator, we should know what should happen. What does Benjamin's number become? 100,000, right? Is that anywhere close to the rest of the numbers? So now his new salary is acting like a what? It's acting like an outlier. So how should that affect the mean of this new situation? Is it going to make it bigger? Is it going to make it smaller? Bigger. Yeah, it's going to make it bigger. Okay, that's what we should see. Okay, so with that in mind, as we go through in column 4, I'm just going to restart copying down 30 and 30 and 45 and 50 and 50 and 55 and 55 and 60. There's my 100. And then we go back down to 50. And then I do a 1 var stat on the last column. I'm going to change it to column 4. Again, that's what's nice about using this kind of feature here, using spreadsheets and so forth. It allows you to kind of look at things a little bit better. So, I'm looking at the mean, and it says 49.2. I'm going to stop. What did we just say out loud? The mean should get what? Bigger. Is 49.2 bigger than 50? No. So before I write down, I'm going to go back and make sure I didn't make any goofy mistakes with my fat fingers. Okay? I'm going to go back in here and make sure that in L4, in column 4, I didn't mistype a number. Oh, I did. Look what number I mistyped down there. I put the second 55 in as a 22. Okay? Remember, just because it gives you something, don't stop and say, hey, that's my answer. We should know that it should increase. I didn't see an increase, which means I typed something in wrong. And so I'm going to go back in there and say, all right, 55. Because remember, 2 is below 5 on a calculator, so it was really easy to do. So now I go back in there, stat, calculate, 1 var stat, get to the bottom. That's a little bit better. Hey, what happened there? It's the same as the other situations. But what do you think, what's going to happen if it becomes out public? Where he chose to give himself the $25,000 raise, payroll is still the same overall average, but what's going to think the employees are going to do? They're going to be a little bit upset that he kept all the bonus amount compared to sharing the wealth? Yeah. Okay.